All right, we're up and running. So yesterday we did long and synthetic division of polynomials. Polynomial division. And we did a couple of things where it came out even. I mean, today we did 2x cubed plus 5x squared minus 23x plus 10 equals 0. You were given a root of 2. We said find the other roots. And we did our division, and it came out 0, right? Maybe I could even have that still. Yeah, where Joel did it, it came out here with a remainder of 0, which means that, yes, it divides in there perfectly. We started with a cubic, and if you divide a cubic by a linear, which is true, so if you go 2x cubed plus 5x squared minus 23x plus 10 equals 0, and you go 2x cubed plus 5x squared minus 23x plus 10 divided by x minus 2. Okay, so this is a cubic. This is linear. So in other words, x cubed term divided by linear is x to what? X to the first. Okay, so remember your rules of exponents. If you have the same base with different exponents, what do? Subtract. So this would be, let me make sure I'm recording. Yep, we're running. Good. This would be x to the 3 minus 2 equals, or 3 minus 1. Gosh, I had 2 on the brain. My bad. 3 minus 1 equals x squared. So if you go a cubic divided by a linear, you had better get a quadratic. And that's important. And we did, in fact, get a quadratic here when Joel did that. We got, what, 2x squared plus 9x minus 5. We got 2x squared plus 9x minus 5. Is that right? What's that, Sean? You can talk. It won't come through. We're good? Okay. Okay, so any questions on that? That's just really, really, really fundamental. We've got to get to that idea that a cubic divided by a linear equals a quadratic. Okay? X to the third divided by x to the first equals x to the second. Any doubts? Please, please, please fess up, admit it. Talk to me, tell me. Any worries about that at all? Really? Would you say so? Anne Marie, you're cool? Okay, I'm glad. Now, here's a question. We did everything lately with these coming out perfectly. What if you get a remainder? That's one thing we want to talk about today. What if you get a remainder? Okay. Well, let's try to find one where we know we do get a remainder. Now, what about if you have some f of x equals 2x to the fourth minus 15x squared minus 10x plus 5 divided by, I'm going to put that in parentheses just so we can see it's one big chunk, x minus 3. Now, this is kind of interesting. Notice, and I did this on purpose, there's no x cubed term. And this is really, really, really important. And if you see it, this is a legitimate function. But there's no x cubed term. Any ideas about what we'll have to do to handle this? Anne? Oh, you're my hero, Anne. You're so right. Okay? So if we're doing that synthetically, what's going to be my divisor? That's the proper term. We should review that. You probably haven't had that in many, many, many years. What's going to be my divisor in this synthetic division problem? 3. Because the root is 3. I'm going to say it's the divisor and root. Okay, not negative 3. And be careful with that. And then Anne is right. We're going to lay out our quartic term, 2. And it is 0x cubed. And our quadratic term, negative 15. And our linear term, negative 10. And our constant term, 5. Yeah. Anyone know what this is called in terms of divisor and quotient and remember that ugly? No. It's called a dividend. Dividend. And you don't have to know that, but it doesn't hurt to review those things. Dividend. Okay. And then we're going to bring down the 2, and then what? Is 6. And don't forget, we're adding, not subtracting, as with long division. Gives us 6. And then what do? 18. And we add them, 3. Somebody other than Sean, Maggie, 9. Then we add them, negative 1. Then negative 3. Then we get a remainder of 2, just like in the old days. Remainder. It's funny to think about that. So then the big question is, what do we do with that remainder? Or I guess we should back up and say, is 3 a root of this? Why don't you graph that right now? Everybody graph that. Tell me, is 3, positive 3, a root? And we'll check it out. I'm going to pause while you do that. All right, after our brief pause, we're back. We've pulled up our Wabbit Emu and put in 2x to the 4th minus 15x squared minus 10x. And make sure I have it in there right. Plus 5. And we graphed that, and it is indeed a quartic. And this is the cool part. If I said to you, what is f of 3? In other words, if you put in 2 times 3 to the 4th minus 15 times 3 squared minus 10 times 3 plus 5, what would you get? Riddle me that, Batman. Now, I'm going to show you a good trick on your calculator so that you don't have to spend a month of Sundays figuring this one out. And some of you may know this already. You can go, if you have this equation in your equation editor, which we do, you can go second table set. You can go down here instead of change table and start table. You can go down here to ask on your independent variable. Ask. Then hit enter. Go to ask, that's second table set. Scroll down to ask. Go to second table. And you'll notice there's nothing here. And you'll think, what a ripoff. But if you put in 3 and hit enter, it gives you that answer without having to calculate every little thing. It's a nice trick. Did you know that one, Peyton? Okay, check it out. So you go second table set. Now, I should say first, you have to have it in your equation editor. Second table set. Go down and turn it on to ask instead of auto. And then go second table. Then you could put in any value you want. F of 5 would be 830. That thing's taken off because it's a quartic. Okay? So, the moral of the story here is if you get a remainder, okay? If you get a remainder, it's a quick way, maybe, for big functions, of finding what that value is. And there's a theorem that says that. It's called the Remainder Theorem. Yeah. And it just says, when a polynomial f of x is divided by x minus a, finish this sentence, the remainder is what? F of a. That's pretty useful sometimes. I got to make that a better writing. The remainder is f of a. Pretty useful. And we'll have, I'm going to stop the recording now and we'll practice some of these in class. So this is just a 9-minute video. Oh, did I not start that again? What the heck? Oh, no, it did. We're good. Okay. It's a 14-minute video. All right, that is all. Have a wonderful day.